Good day, everyone. I'm not a programmer. I'm not completely technically skilled for making things. I'm more a person that tries to solve a lot of problems in media and solve exactly problems that we occur every day. And one of the problems that occurs a lot in this sort of business is things about color. Things that I think normally is one of the biggest things users see as our media. A lot of data underneath it, but the color itself is, I think, essential. Reproducing a wrong color could also take away that the user is going to another website or to another app or to something else. That's the reason why I made this small introduction. These are all Dutch media things, but it is something. What was the question? Some time ago, I get a question from one of the persons responsible for VT Wonen, one of our living brands, and they're selling a lot of stuff in all sort of colors. One of the things is they share their colors in this way. So a designer say to the designer of the web, you must pick a color in hexadecimal or in RGB value or in CMYK value. That's what they said to us. Is this familiar for you? All the same? Okay. And do we always get the same color then? No. Why not? It's so simple. Sorry? Screen calibration. Has anyone calibrated his smartphone?
Yes.
How?
I have a thing on there to adjust for being colorblind.
Okay. May I borrow it for you, and then afterwards he, and then afterwards he, and then afterwards he or she, and is there a unified screen? So this whole discussion is over. We stop. Next speaker. The thing is, there is no standardized screen. That's what we see. I will show it to you, but in print there is a little bit of standardization over time. But today, a lot of you are working with not standardized screens. The problem is, if your assumption is wrong, then also the standardized will not work. So what I try to do today is to make the assumption better. That will not solve the problem that sometimes the color on your screen is different than on your screen. But hopefully it will be more a match. That's what I want to do. And therefore I should also explain a little bit about color. One of the biggest problem is, what is color? And I think we have a very big problem because we only have 3 women in this room, and that are only the people that are mostly not colorblind. Around 0.04% of women are colorblind. More than 10% of the men, we can count how many that are in this moment, are colorblind. In what occasion? It's mostly green or red, but always around red and green. There is not that many in blue and yellow, but more likely green and red. But that will say that if you make a design for men, you should take in account that there should be colorblind people in your audience. Has anyone did that? 2. That's more than 1. But be honest, taking a very big button on some site or some app and make it a color that is not suitable for colorblind, for instance, a green background with a red button, will end up mostly in the same color. Thought about it? Somebody? Very simple to think about. This is color. What is color? Adaptive colors. And what is adaptive colors? You have a light, and the light bulb is blue. And you have a light bulb green and a light bulb red. If you mix them together, you get more light. More light will result in brighter things. If you give enough of that color, it will get white. That's what we do with our eye. That's what we do with a photo, with a camera, with everything. The problem is, we not always have this sort of things. We also have print. And print is not about light. Print is about paper with but some ink on it. And the problem is, ink will only get as result that the paper gets smudged and get darker. So what we tried over time to make it the opposite of adaptive colors. So what we do is we smudge white paper with color and hope that at the end it will be black if we put the colors over it. Will it be black? No. It will always be a little bit of gray, not more than that. But also the problem is this color is a mixture of this and this. Because it's a mixture, you get small pieces of color, that mixture. The light will reflect on that, but will not always come completely back to you. It will always spit a little bit this way, this way. Dus the color will also be more dull here than it is here. More dull over there, 3 colors. So you haven't got an opposite of this. The space that you can make with colors in light is always brighter, more open than you can get in this. But there is another thing. Is somebody aware of this? So if you print something on your color printer, then normally it should be okay. But if you print it then in print, really on the printing press, it looks horrible. A lot of printers have, for instance, HP or Epson, have also got two, little colors, light blue and some other colors to make them more color space. But that's something we're going to show to you. Back to the light bulbs. It is about red, green and blue. Which red is the right one? Fire truck, yeah. A good one, fire truck, or election red. Which the good red one? Who can tell me? The middle one would be the best one. Do you think so? Because maybe for the people that don't see the difference, this will make a mixture that is more greenish. This is a mixture that's more yellow. This is a mixture that is more dull. So it will result in different mixtures, but also result in different colors. So the question is, which red should I choose? Is there a standardized red? Who knows him? I also don't know it. There is no standardized red. What we have done, we have introduced some colors about that. And this is done, I think, in stated somewhere 1940 or something, or before that. 31? Yeah. And that's called 31, yeah. This is called a model. It is a 3D model, but this model tells you every color that the human eye of persons in Europe, to be honest, can see. That means that people coming from Asia see different than people coming from Europe. Please take that in account. Never thought about it, but simple question. The paper in Europe is blue. Everybody says blue. Yes, it's really blue. I will show you. The paper in Asia is red. Because the ground of your eye is completely different from approach. Nobody thought about everything that we see in Asia is the same as we do in Europe. No, it's not true. Sorry. The second thing is, there are colorblind people in this room. What can they see of this amount of color? They can see a lot of things, but they will be having a lot of difficulties in the green part. Everyone. There are a lot of areas where we have problems. Mostly around the middle it will be okay. But at the ending it will always be a problem. Another one. They thought, let's make it mathematical. And mathematical will say, we make a model where we can put a color, maybe this fire red, or this election red. Maybe we can put this color somewhere in this color wheel. And what is the color wheel? The color wheel is in circle axis. This is the X 100, light, no light, 100% light. This is the X A and B. And what it will do is, it will go from red to the opposite green, and it will go to the blue to the yellow one. And what will it mean? That if I make a color, I can say the color will be around 40% L. What sort of color should I have? Gray. Gray. But I didn't say A and B. But it will be dark because it's 40%. If I have an A of around, let's say, 10, a lot this way, then it will be more red. And if I also say L 90, then I get a color that is really not to see, because it's too bright. And our eye will not see that color. This model you can put on any, I've put it over here, come back to it later. This is the complete model in 3D with a normal eye of a woman of around 21 can see. Sorry. But after 21 it will also be decreasing. Also in amount of what you can see, especially the brighter colors will be gone. This is a 3D model, so you cannot say exactly where somebody has a problem, but you can try to pinch it. This is the model more likely if you turn it around. And what we have done, we have put this model into the next thing, and that's a standardized one. When we started to do printing press, we thought maybe it's good that we standardize the RGB, the red, the blue, as a standard value. And that's what you see over here. In the complete model, we have the red put on this spot. So somewhere in this model, you see that the red will be turning around here. So not completely at the end, but somewhere in the middle. The second thing you can see is that we not completely have black. Maybe it's part of it, but could be that we not completely take that last spot of black. The next thing is that we want to put this into print. Sorry. Back again. This is what we can see in RGB, and this is what we can see in print. Okay, I want to have signal red, very signal red. Can we see that? Produce it in print. will be difficult. But seeing, we can see it. You have marker colors. Marker colors are really bright colors and you can see it really. But the problem is, can you also print it? No.
You probably need support colors to do that.
You need a separate color, marker color, to print with the other colors to get this bright color. Because it is a mixture of colors. And what happened with the mixture of colors, I show you in the beginning, it's a mixture of all colors, it will be dull. The problem is that you don't get a bright color like a marker. So in a normal printing process, you never get as bright colors as the colors that come from the printing press itself. Cyan, magenta, yellow and black. That are the only bright colors that you can get. All other colors are mixtures and will not be bright. We have taken a lot of time to make this step from RGB Adobe to CMYK in print reasonable. And we bought a lot of systems for that in this building, but also in Finland, but also in any printing house. We invest a lot of money to get this change of color as good as possible. But what must we do? We must do something because we have big amount of color and we do go to a small amount of color. The problem is, if we do that, we always lose something. I have a picture of this, and the question is, this is what you can see, the colors in this picture. These are all the colors seen in this picture. The problem is, if you take that in account and you want to print this, what I'm going to do with this color that are not going to be printed? This will not be printed, this bright color. It's not possible. The black is not possible to print. What we normally do in our systems that we have in place to go to print, we think we deflate the colors. Deflate will say we get back to the LX. And that will mean that the colors will less bright. So saturation will be less. Because then it will be coming inside. The second thing we do is we make the top and the bottom also decrease. So that we get all the colors inside of the model. The problem is, if one spot in this picture is hugely bright or hugely saturated, then all the other colors will decrease also. Only one marker on a picture will have result on the whole picture. If the marker isn't not the information, why then I decrease then the color? If this color, this purple color is not necessary, why decrease it? If I decrease it, then it will be flattened. You don't see any details left. This knowledge is the difficult one, and we have put a lot of effort in it. Oh, sorry, I will show you. Everything what is blue is not printable. It's only one example. But it goes not about this flower, it goes about this. Does it matter or not? Do you know it? Do you know exactly what I want to produce to the customer? Is this the information or is this the information? That is a situation that you should select. You must decide what you want to see. If you do it automatically, you don't get the result maybe that you want to have. Okay. So what we've done a lot of work and we spent a lot of money to get from this part to this part. And we bought all systems. In the Netherlands we have a publisher server for that. With a lot of printing, they have a lot of systems for that. Very good. a lot of money and always the same result. Because the print part is completely standardized. Ink are standardized, paper is standardized, all things are standardized. So we get a really big effort and a really big result that is always the same. That was some time ago. And then there was no problem, we lived happily ever after, nothing else. But to be honest, sometimes it always goes wrong. For one example, this is a cover of a picture of Donald Duck, Aku Anka. And the problem is, you see the selection of the different CMYK values. I've made a calculation for one print material and one ink. And if I don't tell that to the printing press, and they select the different values, then you get a completely different picture. You see it over here. So telling to the printing press which profile I use is essential to make the good reproduction of the picture. Do I do it wrong? For instance, if I send this CMYK picture to America, it will completely be wrong. Not because it's America, but sorry, but because they have different inks over there. And the same as it is in Asia, they also use different inks. So we should present with an image what is the profile that we use. Second thing, HP started to do a sort of standardized RGB, sRGB. The problem is that sRGB is a little bit smaller than Adobe RGB. We can still make the print go good, but the problem is there is a difference between these two. If you make a comparison, let's see if I have that here. The outside is Adobe RGB and the inside is sRGB. They are both red, green and blue values. So if I say 10, 10, 10, and I do it in sRGB, and I then tell you to you, I don't tell to you that it was in sRGB, and you do it in Adobe RGB, you think that you have the same value. Not true, because there is more color in his environment than in your environment. What will be ending up that the picture will shift to red. That's normally what happened. Otherwise, if his selection is the start and you go to your selection, what will happen? It will shift to blue. So, back again. How do you get a good result of this value? You must define the color set. If you not define the color set, you never know what value will be coming on your screen. What is the normal color set that a mobile phone can have? sRGB, standardized RGB. That is what we normally think should be there. And that's the only assumption that I can do. I don't know if you put your light very tall or small. I can only assumption that it is sRGB. What do all our print material normally still is in production here? Sorry? CMYK, mostly it's Adobe RGB. Yeah, we don't work that much with CMYK. We do that completely in our conversion. But to be honest, all our material is mostly Adobe RGB. So what we do is we deliver to you Adobe RGB in your data set. And you think, okay, great, I'm going to work with it. Did you do the assumption that it's Adobe RGB? Oh, good one. But to be honest, if you don't do that assumption, it will be shifting on your screen on a mobile to sRGB, and it will be completely different. And that will take in account that maybe the user is not happy with it. Simple example. Same value, but different color. environments. Yep. Not on every screen it's the seeable. That's the problem, eh? Yeah. I don't know on YouTube it will be maybe the same almost, but the people in Finland I hopefully see some difference. But it is depending. The problem with VT Wonen was that this color was going to gray, and more to gray, and they want to have this sort of colors, but it was not there, and they do it over and over again, and it was never happening. So back again. Video is also struggling with this, and more than you think. This is a very simple example captured from the internet, and what a person has done, he's put his photo camera in video mode, but he didn't change his setting, and he has before set it in, for instance, Adobe RGB. What's happening? Hopefully you see some difference. This is, I think, more difference you can see. On the right it's completely bright, on the left is nothing. The person has a little bit lack of red on the left side. And to be honest, it's it's simple. It's very simple, the difference, but awareness could maybe making the wrong selection of color of your, let's say, a product. Very simple. This is one from Fashion Chic, I think. Yeah. This bag has no details left. Completely gone. There is no detail because the color is flattened in the wrong space, and there the details are lost. This one, this is a different jacket than this. It's small, but it's a difference. And this one has no details in his shoes anymore. It could be much more than this. The question is, can we solve it?
Make different printers.
But we have no printers because we have screens. And we cannot standardize the screens. Yeah, I like to standardize it, but there is no standardization on that way. But what can we do on our side? What is your work to get it maybe better?
Use the most crappiest screen to try?
Sorry?
Use the most crappiest screen to work.
No, I don't think you must use the crappier screen or the worst screen. Now, I think that the assumption that you make, if you get RGB, you should know which RGB. And you can read that. It's mostly in the data. If it's not in the data, then you must make an assumption. From every picture that is taken over now, you can make the assumption it's sRGB. But from pictures from the past, it's always Adobe RGB. Second thing is, if you get Adobe RGB, you should do something, because reproducing it right away to sRGB will make a shift. So you must do a color calculation. And that's our lookup tables for it. You can get it.
Stored in the metadata of the JPEG, or?
Yeah, normally it's always stored in the metadata of the data. It's stored in the XMP. If you open the file in Photoshop or another program, normally it's stored in the data of the camera itself. And you should read that before you make an assumption. That's the one. But it's the same as video. We're now doing video in 8 bits, and that's called the Rec 707. But we will go to 4K. On this moment it's still the same. But what will happen is a more bigger color space, but that is Rec 2020. But we need also then more values in it. So then the color calculation will also be difficult. It will not be 8 bits, it will be 10 bits then. But what I'm only trying to do is to make you aware that color is something where you should calculate. And you should do an assumption on things you can read. And not to say, I know it, it's RGB. Thank you for your attention.
One question for Hans while James is setting up.
Click.
One sec.
Nobody can see color anymore.
Question for you, Hans? Still?
It's a suggestion actually. When you're doing a photo shoot or filming a film or video, you can make use of color charts,
Yeah.
calibrated color
Yeah.
swatches.
Yeah.
If you shoot a picture of that with the camera you use,
Yeah.
the person in post-production, in print or in video editing, can see what the colors on the chart look like in the footage, and they can match the same colors towards the target medium.
Yeah, calibration we call it, and make a profile. That's very good. I do really love to do that before a color shoot, especially if you want to make nice pictures. But for nu.nl, they don't have the option to put this on some occasion and make the screen. So then the assumption is really necessary to read the metadata and see what is the assumption, and then hopefully it will be a little bit in the way we think we saw it.
Yeah, you can make use of color bars in your video camera.
Yeah.
Or, well, if the camera is set up properly, then you sort of have information
Exactly.
you can use to produce a proper output. Yeah.
To be honest, a lot of people that are using cameras can standardize their way.
Mm-hmm.
The problem is that we have more and more people that use their cameras. What is really good, that's our news and all the things, but we should then also take into account that sometimes it's not completely calibrated.
Yeah.
But let's do really read it. Maybe then we get better color.
Mm-hmm.
Thank you.
Yep.
Yeah, straight to James.
Thank you. Never had one of these before. Okay.
Oh, you found a